I'm Dr. Diana Sturm, and today we're going to go over parts of a geologic topographic map. So for this first video, we're going to talk strictly about where things are located on the map. So this is the map that we're going to be using. You can download this at the Geological Survey of Alabama. And the name of the map is up here in the upper right-hand corner. It is the Quadrangle Series Map 52 plate. And this map was actually created by taking an original topographic map and adding a geologic layer on top of it. It was produced by the Geological Survey of Alabama. So on the maps that we use, either topographic maps or these geological maps, you can see who created it up in the upper left-hand corner. There's additional information at the bottom of the map, both in this section immediately under the topographic part of the map, or in this section underneath this cross section that tells a little bit more about the map. So the original map was this topographic map, and you probably have seen those in class. They're typically kind of green in color, and they show the surface features of the land that you're looking at. So on this map, there is a topographic map underneath, and you can actually see the contour lines that tell us the elevation of the land in this area. Underneath this is the original information that went with this topographic map. So it tells us the magnetic declination. You can see that from north, or from the top of the map, how many degrees, either to the east or west, that this is off from the magnetic North Pole. So remember, the magnetic North Pole is different than the geographic North Pole. Maps typically are oriented towards the geographic North Pole. Unless they specify otherwise, you should assume that they're oriented to the geographic North Pole. This little symbol in this area can tell you whether it's oriented to the geographic North Pole or the magnetic North Pole. Typically, there's going to be a line, straight line, pointing up to the top of the map, and it may have an MN, which means magnetic north, or it may have a GN, which is geographic north. If it just has a star instead of either one of those things, that means that the map is slightly off from the geographic North Pole, and it will have a separate line showing the geographic North Pole and a separate one showing the magnetic North Pole. And there are degrees on either side of this, degrees, and it'll show it in degrees and mils. Now, a mil, M-I-L-S, is not miles. A mil is a part of a sphere, so it's one of the measurements that's used to measure a sphere. So this is in degrees and mils. So that's how we know how the map is oriented, what direction it's more oriented towards. But if you don't have something like this on any map that you see, then assume that the top of the map is oriented to the North Pole. And this includes even maps of Australia or anything that's located south of the equator. On this side of the map, we have a description of how the map was made, what year it was originally surveyed, what year it was edited, what projection that is used to create this map. So we have a lot of making of the map information on this side. In the center, we have the scale of the map. The scale is very important because it can tell you that by looking at an inch on the map, how many feet or how many miles you're looking at on the ground. So we have several sets of scales here. The bars that you see are scales that can be used for measurement, where you can place a ruler up against it, and then you can then place a ruler on the map, and you can just see from line the ruler next to it the distance. This scale immediately underneath the map, where it says 1 to 24,000, is called a fractional scale. And this is a unique scale in that it can be used by people from different countries who use different systems of measurement. So in a fractional scale, you'll notice that it's unitless. So that means the person looking at the map can use the units that they're used to using, and the measurements will turn out correctly. So for instance, here in the United States, we use feet and miles and inches. So if we're using, for instance, inches, the 1 to 24,000 means 1 inch on this map is equal to 24,000 inches outside. So if I wanted to walk along this river here, and I was going to walk along 1 inch of the river on the map, and I actually went to the river in person and was walking along the river in person, then I'd have to walk 24,000 inches in person along the river to equal 1 inch on this map. Now, if I was from Europe, or really any place else in the world, of course they use metric. So in the case of using metric, we would look at centimeters. So 1 centimeter on this map is going to be equal to 24,000 centimeters on the ground. So this fractional scale is very useful for people from different areas of the world so that they can also use the maps with the measurements given. Now, the only exception to this are the contour intervals. So the contour intervals, and I'll talk more about those in a different video, contour intervals are measured in feet. So those are feet in elevation above sea level. You also have on the bottom of this map, you have a little diagram, and it shows several states. So in this case, Kentucky, Tennessee, Alabama, Georgia, and Mississippi. And it shows you where this piece of land is located in relationship to the rest of the United States. So this tells you that this is in the northern part of Alabama. And then here we have a little bit more information on the making of the map on this side. So then we also have down here, we have a geologic cross-section. So this is not part of the original topographic map. And, excuse me, my dog's being annoying. So this was added. This is a secondary part to the map when we added the geology to the map. So this is a cross-section, and it goes from A to A prime. Well, if you look at this map, you'll find that A is up here, and A prime is down here. So this section at this end of the map corresponds to the geology over here, and then this area at the A prime end of the map corresponds to this part of the geology on this side of the map. And so this cross-section extends all the way across underneath the river, and this is the subsurface of what's going on underground. Then we have this side of the map, and this is the actual geological description of the rock units that are represented on the map. So what we're seeing in this case, we see a lot of color on the map, and each color represents a different rock unit. Each color also represents a different time period. So they've made it pretty easy to know how to locate the rock unit and the time period. So for instance, if we look at this red that's along the river area, and you can see there's kind of bluffs along the river, and so we have a rock unit that they colored in as red. And all you have to do to find that particular rock unit, first you can come over here and you can see the red over here under this scale. This top area on your description represents the geologic time period that the rock was formed in. So in this case, the red was formed during the Silurian period. And almost all of the rocks that are on this particular geologic map were formed during the Paleozoic. The only ones that are more recent are those sediments that are right along the riverfront. So those are during the Quaternary period, our current period, and those represent loose sediment that's being moved downstream. So all the rest of them are during the Paleozoic period. So when you look at this map and you think Paleozoic, the one thing you want to look at is, what life forms were there during the Paleozoic? So we know that trilobites and brachiopods and crinoids were very, very common during the Paleozoic, and they're especially common in northern Alabama because we have a lot of limestone formation in North Alabama. So we know that we might have a chance to find some of those fossils in this general region. So if we continue down on this side of the map, you can then look for that same color, and you can move down here, and you can find the exact name of the rock unit. So this is the Red Mountain Formation, and it's the lower and upper Silurian. Lower and upper refers to, lower indicates the older part of the Silurian, upper indicates the newer part of the Silurian. Then underneath is a description of the actual rocks you're going to find there. So on this particular rock unit, we have shale and mudstone. Now when you see the type of rock that's displayed here, I want you to think about what type of environment are we going to find shale and mudstone. We know that the majority of shale is created in one of two ways. It can be formed in the ocean, often the deep ocean, or it can be formed in kind of swampy wetland areas, or maybe even if it's a green or red shale on the sides of a riverbank. So we want to read more about this rock unit. There's also fossiliferous limestone. So again, that's going to tell us that it was a marine condition. And then we also have just some fine-grained sandstone. So we have shale, we have fossiliferous limestone, and we have sandstone. Now, those all point to a marine condition. The shale could be either or, you know, wetland or marine, but when we add the limestone and the sandstone to it, that really indicates a strong marine indicator. So we know that this particular unit, obviously it's a unit, so we have a good time period in this span of rocks, but this represents this particular area right along the riverfront. So as you go through your exercises, I'll ask you to locate different types of rock units, and you can first locate it by color, find out the time period that that rock was formed in, and then you can go below and you can read the description. And I will ask, what type of environment was that rock formed in? What was the temperature like? If it's a limestone of any kind, you should be able to answer that question. Because we know today, limestones only form in warm tropical waters. So for a limestone to form in any area, that means it had to be warm and tropical during the time of formation. So that is the basic components of the map. We also have some symbols on the map, and these symbols represent strike and dip and faults. So if you look closely on the map, you will see some of the symbols representing the dip. So actually there's a number of them right in this area, and we're going to get a little bit more into that in another video. When we look at the strike and dip symbols, this is where we're going to use the compass. So you're going to need to be able to lay the compass right on top of these strike and dip symbols so that you can see the direction of the strike and dip actually on the map. So these symbols indicate what's going on underground. So strike and dip represents rock units that are breaking up at the surface of the earth, and that tells us they're not horizontal. It means that somehow they've been folded or twisted and they're breaking the surface of the earth. And so when we see that, we know that something else is going on underground. And so this cross-section helps us look at that also. But we're going to use the compass and do a little bit more investigation with the strike and dip symbols in this area. So that kind of covers the map, the Geologic Topographic Survey map. And let me know if you have any questions. I'm going to create another video on latitude and longitude and another video on township, range, and section.